Okay, so we are going to build a thermometer now. The directions, you have directions in the lesson plans. Read over them ahead of time. It gives you background information about all the principles that are at work, including the transfer of heat, the principle of expansion and contraction. And that just shows kids, it's a fun activity. What I typically do is centers with weather instruments. And then after you're done creating weather instruments, you have, for this in particular, you have a data sheet, a team data sheet. So they keep up with how much the thermometer has registered as the minutes go by, and then you keep a data sheet together as a class. So it's a really great way, again, to show that quantitative data in this case, and then making your observations qualitative. So what we have here is a 1 liter bottle, which are provided for you, and then 2 liter bottles with the tops cut off. That will be something that you will need to just save. Families can bring them in for you, or if you have family members who drink a lot of soda. So we are going to add some food coloring to this water because we want to be able to see it rise and fall in the straw. So the straw is actually going to be your thermometer. You do actually have thermometers provided to you as well for your kits, so that way you can actually use real thermometers, but also see transfer of heat in this case. And then the lesson plans have some really great springboards for you too. 3, 4. It says 4. I'm gonna add 6. All right. We have our water heating up, so you need cold water and hot water. Again, your building a thermometer lesson plans are very nice and detailed. This was a center that was kind of tougher for some students, so I made sure to visit that table quite frequently. So first thing you're going to do is, with my assembler, fill the bottle, food coloring, and then we're going to roll some modeling clay. We're going to roll it out until it forms a cylinder around the straw. So about, let me see, can't see with the paper. So you are going to, the idea is to be able to fit the clay into the bottle. So I'm going to roll the clay around. Until it looks about big enough. So the directions tell you to that a 1 pound block of modeling clay should be enough for 25 to 30 thermometers. All right. So after you wrap the ribbon around the middle of the straw, and it has a figure for you to see, you're going to place the straw in the bottle and use the clay to seal that off. Taking away as needed. Must be a little more. All right. Don't pinch the straw close, but we don't want any cracks or holes in the clay. So we're just making sure that you know, it's science, so who knows what could happen. Could surprise you. All right, so that means half of the straw is inside the bottle and half is outside the bottle. I'm going to push the clay into the neck of the bottle far enough to force the water up into the straw so that I can see it. So we have boiling water. It's really boiling. And add some more clay. Don't pinch the straw. Ah, found it. Okay, so just trying to work it to where I could see the water in the top. So I just had to add some more clay. Shove it in there. Okay, so you can just see the water line here at the top. Okay, so now we're going to place this bottle thermometer into a 1 liter plastic container. And I'm going to fill that with hot tap water. And then you're supposed to wait 2 minutes and then record. I'm gonna mark where I can see my water on my straw. Can't see it, but I marked where I could see. So we're gonna fill this bottle with hot water and see what happens. I'm going to unplug. It's good. I have to get closer. So you're timing, you're waiting 2 minutes, but all the while you're watching the thermometer. And I know that you guys can't see very well, but I started here, my water line, and the red line is actually crawling up the straw. So I'm about here now when I started here. So you're just watching how the transfer of heat from the hot water on the outside is transferred to the cold water on the inside. Now, this water was a little hot. I don't know if you guys noticed, this would also be a point for you to talk about how the bottle started to shrink. So you can actually see where the paper is loose at the bottom. So again, another conversation to have. And safety first, you've got heat gloves that are in your kit as well that you will get. So the water was hot, but after a couple minutes, what you're doing is you're just recording, and you can have them use any form of measurement that you're working on in math to record how much the water line has risen since you started. And again, this just helps them keep that quantitative data and making those observations. We got a crack in the clay, so this is, you do it so that way you can see all the ways to mess up. So I have a transfer of heat is actually pushing the water out of the clay right now. You can't see that, but there's a bubble of water. So there are all kinds of different extensions and further investigations that you can do with this activity. There's also a student assessment involved. There's, the actual instructions for students, which is very helpful. It shows them exactly what it should look like. And then follow-up questions and team data sheets for you to keep up with. Also, after we make our anemometer, I will show you a sample of a kind of weather station data sheet where you can keep track of data with your very own weather instruments, which aren't always exact, but it's fun to see the difference between the ones that you create and then the ones that you can look up online, which are more exact, and see the difference, and at least be able to see the different changes. You can see the same amount of change. The wind was blowing harder, so they both show that the wind was blowing harder. Just the measurements are a little different. So weather instruments are fun to make, not quite exact, but entertaining, and the kids like it and enjoy it, and they remember them. So let me know if you have any questions.